My name is Ollie Walsh. I'm the chairperson of the BER Association. I'd like to welcome you all this morning to our CPD event, which is on ventilation. Our thanks to our panel. We have Stephen McGovern, who is our CPD coordinator, and then we have Terry Dermott and Bevan Kennedy. I'll introduce both of those in a second. Ventilation, as you know, is a key component in most new builds and retrofit projects. So it's very important to understand the nuances of each system and how these impact on the BER rating. CPD, as you know, is going to be mandatory from next year onwards. So, you know, these events will be more important then. There is a credit for this morning's event, although it's not required under BER, it is available. So after the event, if you want to email our admin with your details, they'll send out the relevant CPD cert. So firstly, I'm going to hand you to Bevan Kennedy. She is with the Mount Lucas Training Centre. And then afterwards, the main body of the presentation, if you like, will be presented by Terry Dermott. He's with Mozart Architecture. He's an architectural technician. He has extensive experience with project management. He's worked in building control, and he currently works with Laois Offaly Education Board at Mount Lucas, where he delivers the NZEB training course and the ventilation course. So I'll hand you over to Bevan, and from there then we'll go into Dermot's presentation. Thank you. Off you go, Bevan.
Hi everyone, thanks for allowing me this opportunity to speak here this morning briefly. So I just wanted to make you aware, if you aren't already, of some of the fully funded training provision that's available throughout the country with regards to NZEB and retrofit. So I'm just going to share my screen there and talk you through the facilities. So I'm here today representing Laois Offaly ETB, specifically under the National Construction Training Campus Mount Lucas banner. But there are 6 centres of excellence nationally, all offering fully funded training for NZEB and retrofit, City and Guilds accredited or QQI accredited. And obviously you can use these towards your CPD hours if you need, as Ollie said, it from next year onwards. So essentially what we have is a fully simulated training facility. There are attic rigs, ventilation rigs, suspended timber floor rigs, everything that you can imagine here in the training centre. And as I mentioned, there's actually going to be 6 of these nationally. So although I'm here representing Laois Offaly ETB, I'm also representing the 6 centres of excellence. Essentially what we have is a simulated training facility, fully funded courses. But the key thing about all this is that the training has been developed with the Department of Housing, the NSAI, the SEAI, the CIF, all of the key stakeholders within every discipline that we have offered training in. As I said, they're either City and Guilds assured or QQI awards. And obviously there would be CPD points available for the hours allocated to the different training sessions. So just a flavour of some of the courses that we offer. We have an NZEB awareness programme. It's 1 day in duration. And on the Siri point system, it's worth 7 Siri points. The NZEB retrofit is 2 days in duration. And again, 7 Siri points. And obviously ventilation, as Ollie has mentioned, is quite a popular topic here today. So we have the NZEB ventilation competency badge there. It's delivered over 2.5 days. And upon completion of that course, upon successful completion, you can prove competency in areas of design, install, commissioning and balancing ventilation systems. So there's a lot within the different courses. And that holds 21 CPD Siri points. So again, just to make you aware that they are there. There are some other courses there, and I have the link for all of the centres of excellence at the bottom. So I'll pop that in the chat in a minute. But more importantly, what are the courses actually covering? So as I said, key stakeholders were involved in the development of these courses, but they're all linking back to the relevant building regulations. So if it's an NZEB awareness programme, Part L and Part F are the integral foundations for those courses. We cover building physics, looking at heat and ventilation losses, condensation, mold formation, U values. When we look at the fabric, we're talking about continuous insulation principle, thermal bridging, air permeability, and the importance that windows and doors or good windows and doors have within the building fabric. We look at building services then and touch on space heating, domestic hot water, more importantly, controlled ventilation and the different ventilation types that are there. We look at lighting, ICT and smart technology. And then finally, we look at the renewable energy requirements, that 20% RER recommendation as per DEEP. So essentially what EPCs, CPCs and RERs we have and how we reduce those based on the Part L and Part F building regs. And then on the retrofit courses, SR54 is the foundation for all of those courses. You must complete the NZEB awareness course before completing the retrofit awareness, because essentially all the foundation, building physics, building services, building fabric is covered within that. But you can see there on the retrofit courses. So we're looking at principles of heat loss, characteristics of insulation and draft proofing, insulating your roof walls and floors aimed at increasing energy efficiencies. So how do you apply the building physics that you learned in the first module and then look at home upgrades in the second module? And like I said, that's a 2-day retrofit awareness program. So I have our own website down here on the bottom, www.mountlucas.ie/NZEB. But the key thing to remember, folks, is that these courses are there, they're available, they're running 2-3 times every month, depending on where you are in the country. And the key thing is that they're fully funded for those in employment through the Skills to Advance initiative. So does anyone have any questions before I hand you over to Terry? I'll pop both of those website links in the chat there, the mountlucas.ie and also the FET page, so that you can access that information if you want after the course. But that's essentially it from me, folks. Thanks very much for listening.
Thanks very much, Bevan. I've been down myself to the Mount Lucas Centre a couple of years ago, looking at a range of different ventilation systems. It's an extraordinary facility with practically every scenario that you would ever come across on site is modelled up there. So it's a great facility to have. Okay, so we'll hand you over to Terry, and Terry can take it from here. Thank you. Terry, are you hearing us?
There we go. Now you should be able to hear me. Good morning, everybody.
Okay,
Thank you, Bevan, for that introduction, and looking forward to spending the next half hour or so with you looking at ventilation in our homes, not only our new builds, but also our retrofits. And quite frankly, ventilation in our retrofits very often is more important than ventilation in our new homes, because we're very often dealing with the old strategy of ventilation being natural ventilation with intermittent extract. So to get straight into it then, ventilation, we get that down there. That didn't belong there. That's better. Right. So ventilation, what is ventilation? Really, it is the movement of air from outside to inside, the movement of air from inside to outside, whether we're doing that through natural means or doing it mechanically. That is ventilation. It's fresh air into our homes, dirty, stale, humid air out of our homes as quickly as possible, obviously helping to avoid the concentration of those pollutants within the home. And in today's world, our ventilation systems are also helping us with cleaning our air. So in other words, if we have a mechanical system with heat recovery, for example, we are filtering that air before it comes into the home. So we're able to keep those pollutants outside. Likewise, we're filtering the air before it leaves the home to make sure that the heat recovery system is not bunged up with additional dirt and so on. Obviously, with the Rolls-Royce of ventilation systems being mechanical ventilation with heat recovery, we're able to substantially reduce those ventilation heat losses. And sadly, in many of our older homes where we have natural ventilation with intermittent extract, our ventilation heat losses can be 15, 20, 25% of our total heat loss through that methodology of ventilation. So we definitely need to find better solutions to that natural ventilation with intermittent extract. Obviously, with our good ventilation system with heat recovery also means we're improving the comfort in the home. Happy days. Now, what's really interesting is that from our point of view, ventilation is important, but air permeability is as important. Right, and what we're saying is build tight, ventilate right. So we want our homes to be nicely airtight, trying to reduce those infiltration and exfiltration heat losses, reduce those risks of interstitial condensation, etc. And obviously, the more airtight we make the home, the more important the ventilation is for that home. A submarine is a good example of that. You're going to build a submarine. It needs to be airtight, watertight. And if it doesn't have a good ventilation system, what's going to happen? You're going to suffocate. All right. So maybe it's a little bit of an extreme. We don't necessarily have that in our homes. We're not going to suffocate in our homes, but we need for our homes to be as airtight as we can get them to reduce those infiltration and exfiltration heat losses, and also making sure we're getting plenty of good fresh air. Also, what's interesting is the impact of the various ventilation strategies on the energy efficiency of the home. All right, so what we've got here is a little case study that was done. We took a particular home and captured all the data into the deep software, and then the only specification we changed was the air permeability level of that home. So if I can start by looking at the first three, let's have a look. Let's have a look at these first three, being natural ventilation. So it's the same house, and as we make that home more airtight, we can see a reduction in energy consumption purely by improving the air permeability or air tightness of that home. All right. What's interesting too is if we look at the last two, they're both mechanical ventilation, one being CMEV. I will be defining all of the ventilation systems in time to come, so don't stress if you don't know what CMEV is, versus MVHR. Having a look at the dramatic difference in energy consumption. And the one that's even more interesting from my point of view is natural ventilation with intermittent extract at 3 cubic meters of air per hour per square meter is using ever so slightly less energy than an MVHR unit at 1 cubic meter of air per hour per square meter. So even though the home is beautifully airtight, the ventilation strategy is shooting us in the foot. So it's a combination of ventilation strategy and levels of air tightness that we need to get right to make sure our home is as energy efficient as we can possibly get it. And that's really what we're all about. So in our new builds, piece of cake. The architect does the designs, we look at the specifications, we can choose an appropriate ventilation strategy. Our retrofits are a lot more difficult. Okay, and that's obviously, I'm really hoping that many of you will come through and do our ventilation course and also our retrofit course. As Bevan mentioned, it's a 2-day course retrofit, well worth looking at, helping to ensure that retrofitting homes is done correctly and efficiently so we can have those homes as energy efficient as possible. Right, so impact of air permeability and ventilation on our homes, really, really important, never to be forgotten. Okay. So from a deep point of view, you're all familiar with this screen. One of the first things that you need to do is to identify with the drop-down what ventilation strategy the home has, the home that you're doing the BER assessment on, be it a new build or a retrofit. So I think you're all familiar with that drop-down. I will be going through all of those ventilation strategies so you can identify them easily. And that's really one of the main purposes of today, is to be able for you to be able to walk into an existing home or look at an architect's drawing of a proposed home and very quickly be able to identify the correct ventilation strategy to then select it correctly here. Okay, so once we've done that, we then have some other information that needs to be captured onto that deep page. From my point of view, this external insulation ducting is a big one. All right, very often overlooked. I will come back to it at the end of the slides to show you why it is so important. So please never forget it, that if your ducting is outside of the thermal envelope, then you need to tick this box, because the system needs to know that all of that ducting is outside the thermal envelope and whether or not that ducting is insulated or not. And obviously any ducting outside of the thermal envelope needs to be insulated. Why? Why do we need to insulate those ducts, you might ask? Well, firstly, heat loss. Secondly, the risk of condensation, not only on the outside of the duct, but also within the duct. Okay, so all of those factors need to be taken into account. So when you're doing a BER assessment of an existing home, you're needing to determine whether the ducting is inside or outside of the thermal envelope. You need to identify that thermal envelope of the building and then determine whether those ducts are insulated or not insulated, if they need to be insulated. So Dave, I will come back to that towards the end of the slide presentation. Obviously, our new builds, part F is where we go to for guidance and compliance with our ventilation. So part F gives us the various ventilation strategies, tells us how to design the system to ensure that our airflow rates for supply and extract are sufficient, not just the minimum, and obviously making sure that the quality assurance pertaining to that design, installation, commissioning, balancing of that system is in compliance with those building regulations. So part F is really the starting point for any of the ventilation strategy we're going to be using. And obviously in the ventilation course, we spend most of our time in part F, understanding part F and making sure we are able to comply with part F. Okay. So I want to go back to air permeability or air leakage, because it is such an important part of ventilation. You might say, hang on a minute, ventilation has got nothing to do with air permeability. Well, quite the contrary, it's got absolutely everything to do with air permeability, because our ventilation strategy will be determined by the by the air permeability of the home. And I'll show you why in a minute. All right, so let's quickly define air permeability. I like the term air leakage because literally it's air coming in and out of our homes through those gaps and cracks and holes in the wall. Okay, so on a windy day, air leakage is particularly bad. Why? Because there is a greater pressure difference created between the inside and the outside of the home. Even on a calm day, purely because warm air rises, you will get exfiltration happening at the higher levels of the home, and you will have infiltration happening at the lower levels of the home. And sadly, that infiltration is cold air coming into the house. That exfiltration is warm air that you've spent money warming that air up, and it's gone out the window or out the air leakage point, be it a leaky window. That air permeability we're able to measure. I think you're all familiar with the blower door test, right? So we're able to measure it as cubic meters of air passing through each square meter of surface area every hour at a pressure difference of 50 Pascal between the inside and the outside of the home. Let's think about that for a second. Think about a cubic meter of air. It's a huge volume of air passing through a square meter of surface area every hour, not 1 cubic meter per week or per month, per hour. It's phenomenal how much air leakage we're having in some of our older homes. Okay. And this is done at 50 pascals. Any idea why they're using 50 pascals? And obviously with a big group, a little bit more difficult for somebody to give me an answer. I'll tell you why. We're using 50 pascals for that blower door pressure test because 50 pascals represents a 32 kilometer per hour wind. That's when our air leakage is going to be particularly bad. All right. With that said, the air permeability level on your deep is not going to be at 50 pascals. All right. Air permeability on deep, we're wanting to use a more realistic figure. So we need to do a calculation. We take our air permeability level. There we have two examples. Air permeability level from the blower door test, and we divide it by 20, with giving us our air changes. Okay, which is a little bit more realistic in terms of average air leakage on your average day. We don't have 32 kilometer per hour wind blowing every single day. So it's really important to remember that calculation that needs to be done to convert the blower door test results in cubic meters of air per hour per square meter to an air changes per hour. So we take that, for example, 10 cubic meters, we divide it by 20, we then capture that air changes per hour into the deep software. Okay. And obviously, air permeability in our homes, poor comfort, high energy losses, envelope deterioration. Why envelope deterioration? Well, envelope deterioration because warm air is able to leak through into the fabric of the building, and as that warm air leaks through the fabric of the building, it's going to be cooling. What happens to warm air as it cools down? The relative humidity goes up. What happens when the relative humidity reaches 100%? Bingo, we get condensation, and very often that condensation might be happening within the thermal envelope of the building, within the fabric of the building. And wet timbers, wet plaster, wet insulation is really not going to do us any favors at all. So we have envelope deterioration. And like I said earlier, the ventilation strategy that you're going to be using in your new build or your retrofit, that ventilation strategy will be determined by the air permeability level of the home. It's not vice versa. All right. So one needs to know exactly what air permeability level you have in your home. So currently our maximum air permeability level on an NZEB home is 5 cubic meters of air per hour per square meter. So any new build, you need to be below 5 cubic meters of air per hour per square meter at 50 pascals. The figure of 3 is highlighted in yellow because that is the cutoff point between being able to use natural ventilation with intermittent extract or continuous mechanical ventilation system. So as you make your home more airtight, that natural ventilation with intermittent extract is not going to be enough. We need to mechanically move that air into the home to ensure that we're getting sufficient airflow rates. All right, so definitely please remember, if you're doing a new build, the first thing you're going to be asking is what is the target air permeability level, and ensuring that your ventilation strategy is appropriate for that target air permeability level. It's not the other way around. We don't decide that we're going to go with mechanical ventilation with heat recovery and then decide what our air permeability level is. We start with our air permeability level target and then ensure that our ventilation strategy is appropriate for that. So let's quickly have a look at our various ventilation strategies. All right, so we've got a couple of screenshots here from the part F. The first one being natural ventilation with intermittent extract. We're all fairly familiar with it. All right, so in our wet rooms, being kitchen, bathroom, utility room, sanitary room, we have that intermittent extract fan. All right, and we have the background vents in the bathrooms, those wet rooms, and the background vents in those habitable rooms. Background vents being literally a hole in the wall, either a hole in the wall with a grill on it or a trickle vent. All of those are background vents. The next ventilation strategy that part F talks about is continuous mechanical extract ventilation, CMEV. All right. So from a ventilation point of view, CMEV is great. It's a good ventilation system. But from an energy efficiency point of view, it's not good. Because why? You are extracting all of that warm air, and let me get the correct color here. You are extracting and exhausting all of your nice warm air from your home 24/7, which means you are then bringing in cold air into your home through those background vents 24/7. What do people do? I've seen it happen too many times. Toilet paper, etc., is stuffed into those background vents to try and reduce that cold air coming into the house, which then impacts on the ventilation system, which means your relative humidity in the home is going to build up. Your pollutants inside the home are going to build up. Your radon levels are possibly going to build up. Your condensation levels are going to skyrocket, which means we have huge problems in that home by blocking those vents up. All right. And obviously the next and the Rolls Royce of our ventilation systems is our mechanical ventilation with heat recovery. Definitely the way the world needs to be going. Easy peasy for new builds. As an overall cost of the home, it's fairly negligible as an overall cost. In terms of ventilation strategy, it is a good ventilation system. Why? Because we have fresh air coming into the home 24/7. We have all of that dirty, stale, polluted, humid air being extracted and exhausted from the home 24/7. So as a ventilation strategy, it's a winner. And because of the heat recovery, it means the energy efficiency of the home is good too. So definitely, please try and aim at using mechanical ventilation with heat recovery system in your new builds and your retrofits if possible. Not always easy. I will show you some examples of alternatives in a retrofit scenario. Okay. So again, those background vents, intermittent extract from those wet rooms. We're talking natural ventilation with intermittent extract here. Looking something like that. So natural ventilation with intermittent extract, really the entry level and probably one of the most common in our older homes in Ireland. As a ventilation system, not particularly good because it's hugely reliant on weather from the outside to move air in and out of the home. Okay, so we're familiar with it there, ensuring that those extract fans are working correctly, making sure that we are getting sufficient air in and out of the house. Okay. Our CMEV system, instead of multiple intermittent extract fans in those wet rooms, we now have one extract fan exhausting all of that nice warm air from those wet rooms. and our fresh air is coming into our home through those background vents in the habitable rooms. Okay, so from a ventilation point of view, it's a winner. But because there is no heat recovery on this system, from an energy efficiency point of view, it's a loser. We definitely need to try and move away from CMEV on our homes. And again, to identify it as a system, it means you're going to need to poke your head up into that roof space to be able to see and find that fan. And you're able to then identify it too, because within those wet rooms, we have those extract grills or registers. So definitely a great ventilation system, but not all that wonderful for energy efficiency with your home. So much so that DEEP recognizes that fact and will then accordingly allocate the poor level of energy efficiency on the home. So those background vents there, we're familiar with them. Sadly, we have this happening far too often, where the homeowner in this particular case is spending a lot of money heating the air inside his home using his radiators. His ventilation system is shooting him in the foot by then extracting and exhausting all of that nice warm air, and he's paying good money to melt the frost on his roof. Such a waste of money. Okay, interesting enough, this particular home is belonging to a colleague of mine, and soon after he purchased the home, he realized that the CMEV system was actually shooting him in the foot. So he has recently upgraded the entire ventilation system to full mechanical ventilation with heat recovery, and it's going to be interesting to see how his energy efficiency improves as he goes into the winter, and I think winter's around the corner. Right up. So like I said previously, our Rolls-Royce is our mechanical ventilation with heat recovery. So our MVHR unit is running continuously. We are supplying fresh air through to those habitable rooms 24/7. We are extracting from those wet rooms 24/7. All of that air is coming through the heat recovery unit, our MVHR unit. Where do you see that unit? You see it inside the thermal envelope against an external wall, right? Not up in the attic. Sadly, that position of the MVHR unit being installed up in the attic seems to be the default position for some reason. And we're desperately trying to get that changed. We don't want it up in that attic space for a number of reasons. Okay. First reason, we want the MVHR unit inside the thermal envelope to reduce the number of meters of ducting outside the thermal envelope. All right, if you have that MVHR unit within the thermal envelope, you have no ducting outside the thermal envelope, no ducting needing insulating, no heat loss, no condensation, etc., etc. Secondly, we want that MVHR unit inside the thermal envelope for ease of access in terms of servicing, maintenance, changing filters. We pop it up into the attic, sadly, and very often it gets forgotten up there. And 2 years later, the occupants of the home wonder why they keep getting sick. They're getting sick because we've got a buildup of bacteria and viruses inside those filters which haven't been changed. So again, please try and keep that MVHR unit inside the thermal envelope. New builds, piece of cake, allocate space in a utility room. Retrofits a lot more difficult. Okay. So the system, and get my slides to move, looking something similar to that. Okay. And obviously air tightness, air permeability on a home with mechanical ventilation, with heat recovery. We want that home as airtight as we can possibly get it. If we can get it down to below 1 cubic meter of air per hour per square meter at 50 pascals, we're definitely heading in the right direction. Okay. In the case of passive house, right, so this course is predominantly aimed at NZEB, but we do mention passive house from time to time, and I'm quite sure you will, in your experience, come across a passive house or two. In the case of passive house new build, the air permeability level needs to be down below 0.6 air changes per hour at 50 pascals. Super airtight, super efficient, hugely reliant on an efficient ventilation system to make sure that the occupants of that home are getting plenty of fresh air and all of that dirty, stale, humid air is being extracted and exhausted. Okay. So coming back to insulating those ducts that are outside of the thermal envelope. Okay, so again, you're familiar with this screen, so I don't need to go into too much explanation on it. All right. So if your MVHR unit has all of its ducting within the thermal envelope, okay, then you leave this box unticked. And we see there this particular home coming in with an A3 rating and coming in at 53.47 kilowatt hours per square meter per year. Pretty good going. If those ducts are not insulated, the heat loss experienced by the system is visible. We're going from 53.47 up to 54.71 kilowatt hours per square meter per year. And you might say, oh, come on, Terry, it's negligible. Well, yes, it is 2.2%, but that 2.2% added to the 3 or 4% efficiency or reduction in heat losses from air permeability, the 5 or 6% from a more energy efficient heating system, etc., etc. You add up all of those smaller percentages, you can very quickly get to 15 to 20%. So it all adds up. All right, so obviously one needs to make sure that you are inspecting that home and identifying the ducting correctly and ensuring that the ducting is or isn't insulated as per the requirement. So our mechanical ventilation system, and it might seem like I'm jumping a little bit, my apologies, I didn't mean to jump so much. I think my slides got mixed up, but anyway, so mechanical ventilation with heat recovery, we are supplying fresh air through to our habitable rooms. Our corridor becomes what we call our transfer zone, and we are extracting from those wet rooms. If you find a home with mechanical ventilation with heat recovery, or in fact any of our homes with ventilation systems, that cross ventilation is really, really important. So be it mechanical or be it natural ventilation with intermittent extract, that cross ventilation is important, making sure that we have those undercuts on the doors or overcuts or the grills in doorways to make sure that that cross ventilation is happening not only on mechanical ventilation systems but also on natural ventilation systems. And obviously that mechanical ventilation with heat recovery system is definitely well worth looking at. New builds, piece of cake. What's really interesting is Scotland have recently passed legislation that as from next year, every single new build in Scotland must be to passive house standard. And to achieve passive house standard, you're going to be needing to have mechanical ventilation with heat recovery. So it's coming, and I'm hoping that Ireland will follow suit with Scotland in due course to make sure that our homes are as energy efficient as we can possibly get them. And to assist with that hugely is that mechanical ventilation with heat recovery system. And it's not just install it and forget about it. Install it, ensure it's correctly installed and maintained. So here we can see filters that need to be changed. Okay. Without changing those filters, we get them clogged. We get bacteria and viruses building up, causing health problems. So part F talks about the three main strategies: natural ventilation with intermittent extract, CMEV, continuous mechanical extract ventilation, and mechanical ventilation with heat recovery, those three. But within those three strategies, there are subcategories, one of them being demand control ventilation. Okay, very popular in our new build developments today. All right. It is very similar to the CMEV system, that one fan operating continuously with those grills in the extract rooms, exhausts. The difference with this system compared to the CMEV is that the supply air through the habitable rooms and the exhaust air is manipulated by the grills in the wet rooms and the grills in the habitable rooms. Okay, how is it done? It's done by humidity sensitive strips and or carbon dioxide strips, sensors, where the airflow rate is manipulated by the system. Okay, so it is a good ventilation system. Sadly, because there is no heat recovery, it's not a particularly good system. As a ventilation system, it's great. It's a winner. But from an energy efficiency point of view, it's really not. Okay. And again, DEEP recognizes that. And the last one that second to last one that I wanted to quickly have a look at, and again, we're seeing becoming quite popular, is the exhaust air heat pump. So we are extracting from those wet rooms, okay? And instead of extracting and exhausting all of that nice warm air, we're putting it through an exhaust air heat pump, which means we're keeping the heat inside the home, which is definitely a step in the right direction. Sadly, we're still getting cold air coming into the home. All right. So it's not as great as full mechanical ventilation with heat recovery, but definitely a step in the right direction. Okay. And then the last system that I wanted to look at was decentralized ventilation, or some people call it single room heat recovery ventilation system. We're seeing it being used more and more on retrofits. It's a great system to replace that natural ventilation with intermittent extract. Why? Because the units that we have are installed into that hole in the wall. These are 150 mil diameter. Our average hole in the wall is 100 mil diameter. So yes, we need to recore them, but we can then insert them into that existing hole in the wall, and we're getting plenty of fresh air into the home, and there is heat recovery with the system. Okay, if you're not familiar with these, really nice system to be looked at. They obviously, we're looking at this particular one, which is used in habitable rooms, and we see here a habitable room. They're working in pairs. Okay, so this particular unit will be bringing fresh air into the home, and at the same time its partner on the other side of the room will be exhausting air. The heat recovery is reliant on that movement of air alternating. So the way the system works is that this unit is bringing fresh air in, that unit is extracting, exhausting, and they alternate direction every 70 seconds. So 70 seconds later, that unit starts bringing fresh air in, and that unit starts extracting. So we're getting fresh air moving in and out of the house, and because of that porcelain core, we're getting as much as 80% heat recovery as per the specifications from the suppliers. Okay, so definitely well worth looking at from a retrofit point of view. We are seeing it used from time to time in new builds, but generally this system is used in a retrofit scenario. Decentralized. Okay, so there is the system helping us because we're not needing to find space for ducting. We're not needing to try and find space for a heat recovery unit inside a home where there is no space for it. So definitely the decentralized system is great. I believe there are 3 systems on the market currently here in Ireland, and they are definitely well worth looking at in terms of upgrading your ventilation system from that natural ventilation with intermittent to a more energy efficient and continuously operating ventilation system, meaning that your fresh air in the home is going to be good, and it's not ice cold air coming in anymore. It's now tempered air being brought into the home because of that heat recovery. So definitely well worth looking at. Definitely, it really is an exciting product to be looked at, and pretty much that's what I wanted to say on ventilation in our homes. All right, we are now, oh, nice one. I've done it pretty well. So thank you very much for your time. I definitely would like any questions, if there's any questions, for us to deal with them. If I can't answer the question through our chairman today, definitely will be able to handle any follow-up questions by email, etc. I look forward to it, and thank you very much for your time. I hope you have found it interesting, fairly basic, but really important that our ventilation in our homes is up to its job. Thank you very much.
Thank you, Terry. That was very good, very informative. I see there are a couple of questions there, and Stephen will handle those. Just by way of my own thing, in relation to that Luna system, I presume that has to be wired. Each individual unit has to be wired.
Thank you very much. Nice question. Yes. Some of the latest models on the market are using Wi-Fi and or radio link, but yes, they do need to be wired. You can see the little green dotted line there through to the control panel. And obviously they also need their own electricity. So yes, there is work. They're not a DIY solution. You have to be getting the company in. They will check the design or the ventilation design of your home, making sure that it is in compliance with Part F, and it's not cheap by any means, but definitely from a retrofit point of view, well worth looking at.
Yeah, and presumably it would be possible if there was a couple of problematic areas or particularly problematic areas in a house, that would be a solution in those areas if it wasn't, if people
Definitely.
didn't have the wherewithal to do the whole house.
Definitely, this is one of the systems which can be done or installed in phases. So as you say, for example, you might find, for me personally, I would start with my bedrooms. I would want to try and reduce that cold air coming into my bedrooms, because that's where we're going to see most of the time people start blocking them up with toilet paper, and then possibly move on to the bathroom, and finally end up in that living room. If you're not able to do it as a once-off, it can be done in phases.
Okay, fantastic. Will I pop you over there to Stephen if you have any questions?
Yeah, thank you very much, Terry, for that presentation. We have a few questions coming in on the chat and coming in privately on private message. So keep them coming if you want, or we can respond to them later if we don't have time today. One came in there, and a great point, I think, given the exposure is so important, as outlined by your explanation of the 50 pascals and the 32-kilometer winds. Should we be treating coastal houses in Donegal the same as sheltered houses in Wexford? Should there be an allowance indeed for this?
Very interesting question. It is a good question, because quite frankly, a home on the west coast, because its exposure to wind, is going to have a higher level of infiltration and exfiltration, which means your heat losses and so on are going to be worse than a home on the east coast or in the Midlands where I am. So I think possibly one should be looking at changing. I think that's also where it's important to use the blower door results as opposed to just the defaults, because a blower door result will be a lot more accurate in terms of air permeability levels, and not just using the default from DEEP.
I would add there too, in terms of using the blower door test, there is a selection, a drop-down selection there to determine whether the house is highly exposed or partially exposed, etc. So some of that figure is accounted for in the reading that you would get from your blower door test result.
Yeah, and I think from the point of view of actually measuring the heat loss of houses, we shouldn't be taking Dublin airport data, I think, for the whole country either. It's probably something that needs to be worked on, as well as the actual temperature, indoor temperature, the realistic indoor temperature of houses, as opposed to what's in DEEP. The next question there is from Taha. Sorry, Taha, if that's not how you pronounce your name. And I kind of broke it down. I was trying to figure out exactly what you were asking, so I kind of broke it down to see if I could figure it out. He said in new homes specifically, air tightness results are too good. So I don't know if that's a point or not. And due to, I'll go more with your second point, due to the environmental changes, overheating is another rising problem. It certainly is. If a house has good air tightness result, how does ventilation help to prevent overheating?
Nice questions. Yeah, definitely. Your air tightness, the more airtight you make your home, the more important your mechanical ventilation, and your mechanical ventilation running 24/7. So you can make a home super airtight. If you have that mechanical ventilation running 24/7, you're not going to be feeling stuffy inside that house, because you're getting plenty of fresh air coming in. All of that humid, stale, dirty air is being extracted out of that home 24/7. So the more airtight your home is, the better, specifically if you have the heat recovery system. Overheating of homes. Largely, our overheating is being caused by excessive solar gains. And that's the important one, is to make sure that our beautiful big south-facing, southeast, southwest-facing windows have cover in the summertime. We don't want that summer sun coming in. We do want that winter sun coming in. And I think that's really important, is to try and shade those windows in the summertime. And sadly, we're seeing far too many homes where they have these beautiful, huge expanses of glass facing south, and then they wonder why they overheat. Okay, so definitely, obviously the ventilation system will be helping to mitigate that overheating, because the mechanical ventilation with heat recovery system, you're able to put it into the bypass mode, where you're not doing any heat recovery. So that will help to mitigate that overheating. But definitely overheating is a problem in our homes, and largely because of too much solar gain. And the third part of that was?
No, I think you've pretty covered
Yeah,
that, I
great.
think, Terry. John B asks, how regular is recommended to change filters in your MVHR?
Nice question. First point of call is the instruction manual from the system supplier. We've seen different systems, anything from 6 to 9 months. Most of them are 9 to 12 months. Some of them recommend you hoover the filter every 3 months and replace it every 12 months. There's even one manufacturer where they say you can take the filter out and wash it and replace it, and take it out, wash it and reinstall it, and only replace it every 2 to 3 years. So please, there's no straight answer on that one. Is follow the guidance from your supplier, on the system supplier, and see exactly what there is. And again, depending on where you live, if you live in a suburb in Dublin, you're going to be changing those filters more often and cleaning those filters more often than if you live like I do in the Midlands, outside of a town. I'm in the countryside, so the air is generally cleaner compared to a busy Dublin street. So definitely look at it and follow the guidance from the supplier.
As a rule of thumb there as well, you should advise your homeowner, if you're in a position to do so, not to turn on the equipment until the builders have well gone, because there's a tendency that the equipment is in and installed and commissioned maybe a couple of weeks before the build process is completed. And in those last couple of weeks, as you know, in most build projects, there's hoovering and cleaning and tidying going on. So there's a huge amount of excess dust and fabric and whatever going through that system that it was not designed for. So better to wait until all that's done and then turn on your system once it's in a habitable state.
Agreed.
I presume you should change the filters probably quite soon after all that as well.
Yeah, I would
all the
advise so.
extra
Yeah,
stuff I mean, your house is giving off a lot of dust for quite a while after you build it.
Yeah, and there's stuff coming off cleaning products or building products as well, etc. So that's all been captured in those filters. So definitely in the first couple of months of installation, I would address the issue with the filters, and then maybe, you know, whatever it is, whatever the manufacturers advise thereafter, 6 monthly or whatever the case may be.
Yeah. I'll rock on there. We'll try to get through one or two more questions.
Stephen,
Liam asks, how many and which of the single room systems on the market can be specified to comply with one-stop shop grant requirements for DCV? So I don't know if you would know that, Terry.
Off the top of my head, I don't. I do know that the system distributed and marketed by Partel, actually the one that is on the screen there, can be made compliant with the building regulations quite easily. So assuming that it's compliant with the building regulations, one would then hope that the grant requirements are also achieved, but I'm not 100% sure on that.
Yeah, I feel that maybe Liam is asking from painful experience, maybe that it wasn't accepted possibly on a grant scheme. I suppose we'll have to look at that. Maybe it's a question we should put to the one-stop shop department. And just similarly on that, and Mark asked, how do we enter Luna system in deep? Mark, we had Partel here about 2 years ago, and they gave a presentation and explained that. So if you go back to the website and find that presentation, all our webinars are online. So I guess I'm not sure if Terry wants to attempt to answer that. Feel free to do. But I think
I'm happy if
great. Okay, yeah, we
if Partel came in. That's right from the horse's mouth.
Yeah. No, we had a great webinar on it. So John asks, does the choice between DCV and decentralized MVHR also depend on the air permeability of the house? Can DCV tolerate more leaky houses? Example, with suspended ground floors. So I guess the question is, does the choice between DCV and decentralized depend on the air permeability?
Not really. No. If you have mechanical ventilation, or you are obliged to have mechanical ventilation once the air permeability of the house is below 3 meters cubed per hour per meter squared. Within that, then it's sometimes discretionary as to which ventilation system you use. But as Terry has pointed out, the Rolls Royce and the best system is the MVHR. If the building can accommodate it, in a new build it probably can, but in a retrofit it may or may not. And so therefore then you're looking at alternative options, the like of your DCV or the like of your Luna system, etc. But Terry, you might have some insight on that as well.
Absolutely. I think the air permeability level of a home has a huge impact on the efficiency of that heat recovery. So if you have a terribly leaky home, your efficiency expected would be 85–90%. If your home is terribly leaky, your energy efficiency of that heat recovery can come down to 30–40%, purely because of that cold air coming in and that warm air being extracted through those leaks. So definitely air permeability and efficiency of ventilation systems is huge. So think about using your hoover to hoover the car or to hoover the carpets on. If you've got slits in the pipe, all right, your hoover is not going to be working very well. Okay. Likewise, if your dust bag is clogged up full of sand and whatnot, the hoover is not going to work very well. And that same principle is onto our ventilation systems. We need for the ventilation system, for it to work effectively, we need, especially the mechanical ventilation, we need for that home to be as airtight as we can possibly get it.
Okay. We're almost out of time. If there's one or two other quick ones there, Stephen, we can run, and if not, we'll...
There's one good one there from another John G. This, and just on John's question, of course, Part L does have sets air permeabilities you must achieve. You know, if you go below 5, you are then moving away from natural ventilation, actually legally have to. And then below 3, you must move to mechanical. So just in case John was making that, maybe that's the point he was after, to check Part F, and you'll find all that. And John G says, regarding MVHR, where ducting is evidently outside the thermal envelope that is in the attic, what percentage of observed insulated ducting is acceptable to allow non-default input into deep? So to I guess, to not tick the box, I guess. So what is the level of insulation, I think, is the question there, that's acceptable?
Right. So, yeah, if I can come in there, in terms of the specifications from our building regulations, we need a minimum of 25 millimeters of insulation with a thermal conductivity less than or equal to 0.04 watts per meter Kelvin. Now, how do you determine that? By looking at it? Very difficult. And that's where, when I do the ventilation course, I make it quite clear to anybody doing installations is to please take photographs and keep the receipts and so on of the insulation, so that they can then pass that on to the BER assessor, because the BER assessor needs to prove absolutely everything that he needs to prove. So it's never easy to be able to measure how much insulation is there, but the specifications are minimum 25 mil with a thermal conductivity less than or equal to 0.04 watts per meter Kelvin.
Great, thanks, Terry. And that's on section 2.6 of the DEEP manual as well. Exactly what Terry said there. I just checked it, so spot on, Terry. We have a couple of follow-up points, but I think we're good. We've got through the bulk of the questions there. We want to keep on time.